In this video, I'm going to be going through some common security vectors in web applications and how you reduce the risk of them, in some cases eliminate the risk, if you're using ASP.NET. Some of these ideas will apply to other frameworks as well. Well, they're all vectors that you can get in any framework, but some of the solutions I give are specific to MVC and ASP.NET. So for those of you who are on my course, this is going to be very similar to what I talked about in the lecture, but I think it's that important that it's worth repeating it here. So these are going to be more practical examples. In the lecture, I go through some theory about risk management and how to evaluate risk, whereas this is just going to be the section on these are the key risk areas. These aren't all of the areas, but these are kind of the main things that I'd expect you to be considering in your web application. So the first one I want to talk about is cross-site scripting, which is probably the most common problem or common attack, and is by far the number one vulnerability on the web. And what it's to do with is, if you have a dynamic web application, at some point you're taking user input and you're going to be displaying that on the web page. So this user input will be put into the HTML somewhere. And if you don't check that input, if you don't sanitize it, then it's possible that an attacker could put a payload in there, which is something like a JavaScript script or some kind of malicious form or something like that, which will do something bad. So there's two different types of cross-site scripting. There's passive injection, is when this unsanitized input is saved to a database, and then all users to your website will get it displayed when they visit your site. And then active injection is when this input is immediately displayed on screen, so the input is part of a request and the same person who made that request is getting the payload and the malicious script in their browser. So we call the string or the script that was entered by the attacker is called the payload. This could be like a SQL inquiry. This could be something that deletes things in your database, or somehow does something you didn't initially want your user to be able to do. But often it's a JavaScript script. Now, how bad can this be if someone puts JavaScript into your page? What's the worst someone could do with JavaScript? Now, the browser deliberately restricts JavaScript's access to a user's operating system and files. And I've made some JavaScript games, and probably it was the first barrier you come across is if you want someone to be able to save some data on their computer, it's something you just can't do through JavaScript for these security reasons. What you can do with JavaScript is you can access any object that web page has access to. For example, a cookie. So someone could write a JavaScript to get your cookie and send it to their own server and then start impersonating you. JavaScript can make changes to the browser's DOM, so it can change what the website looks like. Usually these kind of attacks are more kind of not so serious in terms of stealing something and pretending to be someone else, but are like, I don't know, changing a headline on BBC website, for example, would be in it, something like that. And can use XML HTTP requests to send HTTP requests anywhere it wants. And there's some really scary stuff actually with HTML5. So there's lots of really cool APIs with HTML5, and you can get things like where is the user located, but you can also get control of a user's webcam, which is kind of scary. So it can be quite serious. So the two types I told you about were passive injection and active injection. So passive injection is when the payload is saved to the database and everyone who visits your site will see this. And somewhere this happens a lot is if someone implements a really simple comment system, or like a guest book used to be quite a popular thing. Thinking back to like GeoCities websites, is that you would have a guest book and you would say, "Oh, leave a comment in my guest book. Let me know what you think of my website." And people would be writing these using very simple PHP without doing any sanitation. They're just taking a string that anyone can enter, not even requiring you to sign up to a website, maybe. So you can just type in a string, and that string gets saved to the database, and everyone who visits your web page sees all the strings that have been added. And you can imagine what craziness ends up in there. Something that I have to admit I've done in the past is web games that have online leaderboards. So in my situation, I forgot to sanitize an input for the username, so someone could sign up for my game and make their username some kind of JavaScript script, and then when someone views the leaderboard, they were getting this script in their browser. So yeah, that's what I said just now. So you could argue this is the worst kind of attack because it doesn't just affect one person. It puts something in your database and it suddenly will affect everybody. When it happened to me, again, this is the first web application I made, and I didn't follow very good practice, and it took a very long time to figure out where this was happening in my website, because the JavaScript scripts can do lots of strange stuff that make it very hard to figure out where is this coming from, and they can change the whole look of your website. So here's an example. I've a couple of diagrams I'm using from this website, so I didn't make them myself. So for example, this is like a flowchart that shows the kind of process. So the attacker here posts a script to your website. And so in this case, we're looking at a basic comment system. So they're putting in a comment that has a script that says this. And what this is doing is it's telling the browser to make a GET request and actually send their cookie to the attacker's server. And on the website, it's simply going through the database and printing the latest comment without checking it. So this is the attacker puts that on the website, and then a victim goes to the website to look at the latest comment, gets the response, and the response has got this script in it, and then they don't even know this is happening, and their cookie is sent to the attacker's server. And so you can see, this is pretty bad. If someone's got your cookie, they can pretend to be you. So the next one is active injection, which the payload isn't saved. It's actually delivered by the user who is being attacked, which kind of, when you hear that, you think, well, how is that possible? But this is usually comes from something like a phishing attack. So you might have a link that says, oh, come and check out this thing, it's really cool, and you go there, and unknowingly you're actually not going, you're going to somewhere and doing something bad to yourself, basically. So it's whenever a website doesn't sanitize an input and then immediately feeds it back to you. And you might think, as a developer, you might think, well, this input is coming from the user, so they're not going to write anything that's going to damage themselves. But someone else could write the same cookie stealing script, put that in a URL, send that to someone and say, oh, check out this cool website, and then you're providing the attacker with this vector to allow them to get this script into someone's browser. So in this case, all the attacker needs to do is get someone to click on a link that they've made. So here's the kind of flow for this, is the attacker would send a link to the victim. So in this case, we've got a website here that is a simple search website with an input keyword, and in the response, it prints what you searched for. So just that text. So you send this link to someone, unknowingly they click on it, and that's step 2 here. They then do that get with this attribute that's got the script in. That script comes back, and then they've sent a cookie to this attacker. So how do you prevent this? Well, the key overarching thing with preventing this is firstly not to trust any input that's given to you by a user. Be paranoid about it. And the first thing you can do is HTML encode everything. And what that means is that the string you get, you don't put that raw string back to the user. You go through it, and any characters that are special HTML characters, then you encode them so they would appear in HTML. So instead of just putting like a left bracket, a left triangular bracket, you would put whatever the character number is, whatever the HTML encoding is for that. And then it would appear, the user would see the script rendered, it wouldn't just run. Okay, that you would see the script as the string in the browser as text. It wouldn't be interpreted as JavaScript or HTML. It wouldn't be interpreted as HTML. So with ASP.NET, pretty much all the encoding, HTML encoding, is done for you because it expects you to be doing this. It expects all the text, anything that you, any strings that are coming from your model, it encodes this by default. But you can use the HTML helper HTML encode. And also, if you're doing something where your user input ends up being a HTML attribute, then you need to use attribute encode, which is slightly different. And people can do some really dangerous stuff with attributes. So for example, you might have something where you ask a user to give you a URL to an image, and then in your application it puts that URL as the source attribute in an image. So you could hide some scripts and stuff in that source attribute. So that's why you have this attribute encode as well. Anything that dynamically sets URLs, you should use URL encoding, which is different to HTML encoding. So there's a URL helper, which you can use, URL encode. And then the other thing, which this is a common mistake, is you need to think if there's anything that you're using that ends up in JavaScript. So you might be using jQuery, and so anything that's in JavaScript, you should JavaScript encode that as well. So the frame, don't expect the framework just to do this stuff for you. You have to think about it. Think about where these problems might occur. Where are you taking user input and try and display it back to the user. So the next vector is cross-site request forgery, and this can be quite damaging and dangerous. So what this is doing is it's using cross-site scripting to get a script into a web page that's executing an unwanted action in a web application that you're currently authenticated in. So it's making you perform an action you're allowed to perform that you don't want to. So probably the best way to illustrate this is with an example. So imagine that your bank account has a really simple way of transferring money, where it's this get request, and it's got two parameters: the account you're transferring it to, so Bill's account, and how much you're transferring it. Yeah, and you can see this in the it's designed really badly, and you can see it in the URL window, so it's so easy. You're like, oh, that's how this is working. Now, so you see that, you see how simple this is. It could even be just a form. You can still fake that. But let's do this get. Let's say it's a get, and you make a URL where you change the account to your account and the amount just to 1. So if anyone was logged into their bank account and clicked on this link, they would send you £1. Okay, so because there's no check here to see if you're already logged in, you're authenticated to do this operation. So what you need to do then is find people who are logged into their online banking, send them this URL, and when they click on it, it will transfer that money to your account. And if you set it to be like a small amount, they might not notice it. So you get them to click it lots of times. And you could hide this on a popular website, and not even just put it on a really popular website and just say, well, probably there might be 10 people who are Maze Bank users, and they'll come on here, and they might just happen to be already logged into their online banking in another window, and then this URL would transfer money. So you could even if this was a form using a post request, you could build a hidden form. So you could build a complete form and hide it in the HTML so it's not visible, and still do the same attack. So the key thing here is that you're finding someone who's authorized to perform an action that you benefit from or damages them. So you're not trying to break into their account, you're getting them to unwillingly do something for you, unwillingly send you money using this. So how do you prevent this? Well, this attack relies on the fact that if I log into my online banking, that I stay authenticated for a long period of time. So what you need to do is, in your application, you need to make sure that any request for a transfer or any request was done so willingly by the user. And the way you do it, or the way that people do this, is to include a hidden input to every request. And that hidden input is unique for the user's current session. And a session might last, say, 5 minutes. And that's what in MVC, in ASP.NET MVC, these anti-forgery tokens are all about. So when you begin a form, you add this helper anti-forgery token. It's adding an extra input to the form that you're building. And then in the controller, you add this attribute to the method that's validate anti-forgery token. So this will only call if the anti-forgery token is valid. And that value is stored in a session cookie in browser's memory. So those tokens have a short life and are very hard to guess, so it almost eliminates the risk. For this to happen, like, I don't know how you'd break this. You would have to, in this fake URL that you created, you'd have to have, in addition, the session ID for the user. So hopefully you can see how that really makes this suddenly more difficult. So cookie stealing is another danger. So we looked at how you could steal someone's cookie earlier when we looked at cross-site scripting. And cookies are things that identify users without needing them to always log in. And there are two types: session cookies, which we talked about with the cross-site request forgery, are stored in your browser's memory, and they're transmitted during every request. And there's persistent cookies, which are actual physical text files stored in your hard drive, and they're transmitted in the same way as session cookies. Session cookies are forgotten when the session ends, but persistent cookies are stored on your machine and help a site remember who you are. So if you get someone else's persistent cookie, you could log in and do whatever that person's authorized to do. And so we looked at a script earlier that uses JavaScript to send the cookie to any server you want to. So we basically want to figure out, how do we stop this happening here? We want to find a way of stopping this. And it's actually pretty simple. You can basically stop script access to cookies using HTTP only flag. And the flag tells the browser to invalidate the cookie if anything but the server sets it or changes it. And it stops pretty much all cookie issues. In ASP.NET, you need to set the flag in the web config file. It's not done by default. So in your web config file, you go down to system.web and add the flag here, and that makes sure that there's no way that someone can steal your cookie. And of course, the other way of preventing it is if you haven't got any cross-site scripting risk, then it's going to be very hard for someone to get that script onto a user's browser. Overposting is another security risk. This is introduced by the model binding in ASP.NET MVC. So when you build up a form with scaffolding, and how things are working is a user fills out all the data in the form, and this is sent via a HTTP request to your server. And then a model binding system looks at all the inputs in that form and matches them against the members of the class that defines that model. So if we have a user review system here with product ID, name, comment, approved, review rating, you might have a system where you actually want someone to approve a review before it's posted, which makes sense. Now you would then build a form. You have this as your model, and you do your scaffolding, and your scaffolding by default puts an editor window for each of these things. So you'll see an editor for name, comment, approved, and review rating. And you think, right, actually, I don't want approved to be something the user can edit, so you just delete approved. You just delete that form element from the form, and you say, oh, excellent, right, they can't edit it. Well, they can. What they can do is they can construct their own post request and include approved and also review rating. So review rating is what other people have rated this review. So they could use web development tools to create their own post request and add approved equals true and review rating equals 5 to the header, to the data that's sent with this request. And then the model binding would see that data is in there and go, oh, approved equals true. There's a parameter here, approved, and this here is approved equals true. Yeah, I'll set it to true, even though that's not what you wanted. And that's called an overposting attack. Is users taking advantage of the model binding system to edit values that you don't want the user to be able to edit. Now, to prevent these, you use the bind attribute. And so what you do is you can set this in the actual class level. You don't have to necessarily set this in the way we've done it, or in my lectures, is you can do it in the controller class, but you can also do it in the actual class definition. So, or the controller action, I mean. So you have the bind, and then you say which parameters do we want to include in the binding. And so here we just want name and comment. So what that means is the model binding will only look for name and comment. It won't even consider these other things. So you'll have to write logic in your code to set these up. And in some cases it might just be a case of, well, approved is always going to start as false. You can use a blacklist approach, so you could say what not to include, but it's usually whitelist approaches. What's allowed is usually safer, because then if you forget something, you make a mistake, then you're not adding a vulnerability by that bug or mistake. Whereas if you had a blacklist approach where you're just saying which ones don't I want you to do, you might forget to put review rating and then there's a vulnerability. Whereas if you forget to add comment, then it's a bug that just causes some errors for some users, right? Which is better than having a bug that causes a security hole. And the scaffolding automatically whitelists everything, so be careful. Now, there isn't a better solution to this, which is to use view-specific models. So instead of having your model being review, you'll still have this class, and your database entry will still be based off this, but you can create a review view model that only has the two things you want to get from the browser. And then you change your code to work, using this. So this would be the model that your create view uses. Is that so you're separating this from your database entry, and at some point you'll have some kind of logic that takes this review model, which is the model that's passed from your view to your controller, and converts it to this class, and that gets put into your database context. Yeah, so it's a view specific model. Have a look online if you're not sure about that. It's something that I will have mentioned quite a few times throughout the course. So another problem is open redirection. So this is caused when a URL, a redirect URL, is passed as a parameter during a request. So for example, maybe you have something where you want a user to change their password. And if you're not logged in, what might happen is that the way you've written your web application might end up with the following request. So you've got a get account log on, and then the return URL is where I came from, where I wasn't logged in when I went to change password. I clicked change password, and it's like, oh, you need to log on, but we need to know where you came from because we want to redirect you to that page once you've logged in. In this case, so we're passing the URL we came from as a parameter. So somewhere else you might see this sometimes is some websites allow you to pass a URL as a parameter to tell them where you came from. So maybe you have some kind of scheme where a referral scheme where you get money based on how many people click to a store through your link, for example. Sometimes you see it like on YouTube with Let's Plays videos. I think Itch has a scheme like this. So if someone clicks on a store link from your video, they might have passed a parameter through that URL, which is where did I come from? Yeah, otherwise you wouldn't know. They probably do it with a some kind of key, but you can imagine there are examples where you want to know what URL you've come from. So not validating this is a vulnerability. So an attacker could modify this value to redirect a user to their own website. And something you could do, say for example, with this one, is you could, let's say not a change password. Say we could pick any page on your website that requires you to log in. So let's say it's gallery, right? So you go into the gallery, you want to look at something, or your email, let's say, whatever. You could change this URL to another website. You click on it. It takes you to a website that looks like the one you just came from, and it says that your login details were incorrect. So you've just typed in, this is a login page, so you've just typed in your username and password, pushed enter, and then you get another page that says, oh, that's not correct. And so you think, oh, I must have just done a typo. You retype in your username and password, push enter, but what you didn't realize was this URL was a different website, was the attacker's website, and you've just typed in your username and password on their website and sent them your username and password. Okay, so hopefully you follow that. So you can fool someone into thinking they're typing in a username and password on the valid website, but it's actually the attacker's website, and you're just giving them your username and password. You could even, the attacker could be really clever, and once you've given that information, could then redirect you to the page you thought you were going to before. So as far as you're concerned, nothing went wrong. And if they're very clever in designing their fake website to look exactly like your application, then your user might not have a clue this happened. And the way to stop this is to check that the redirect URLs are local, essentially. So you've got this function that's redirect to local. So when you make the request, so this is actually part of the login system, the default login controller. So the model here is going to include our username and password, and then we've got the return URL, which could be any page on our website. So this could be the gallery, this could be the change my password or whatever. So what happens is first we check to see if the model is valid, and if it's valid we return the view. So it's invalid. If it didn't work, it will return and it will say, oh, your username password was incorrect. If it's fine, we try and sign in, and if it's a success, we return redirect to local this URL. So this is going to check that this URL is a local path to the server, and if it's not, you'll get an error. So that means immediately you've stopped this problem. You can't just have anyone putting in their own URL here. And there's also a URL helper method called URL is local URL, so you could use that if you wanted to. Another danger, which is quite common, which is another danger you could have, is error reporting. So by default, if you have an error, you get something like this. And here is the version information for your server. That could be really useful to an attacker. So we don't really want to give this much information. And so what we can do is we can add an attribute to our web config called custom error. Custom errors mode is on, and then you don't get this version information. There's some errors actually you get even more detail than this. So this is quite an important thing. And something, so really this is something you should only be using when you're troubleshooting and developing, and then when you deploy you've got to make sure that you do this. And there is a deployment attribute that's quite useful, which you can set retail equals true, and it automatically sorts out all this stuff for you. It sets custom errors to on, it disables trace output and disables debug. And that's like a really important thing to consider. So the main things I introduced here: cross-site scripting, cross-site request forgery, cookie stealing, overposting, open redirection, error reporting. And you should design your application to mitigate these risks and others. And there's some good places online to find information on security risks. But one thing to remember is that the web is constantly changing, and so you, as a professional web developer, you need to keep up with this stuff. And you should always be designing your application with security in mind. So this is not an exhaustive list. This is not every vector. I can't teach every single vector in this course. I expect you to go read up on this stuff. And it's important you understand it. So any questions, as usual, ask me in the comments. Follow me on Twitter at Dr. Sean Walton. Let me know if there are any other videos you want me to do. Thanks for watching.